Hello everyone, welcome back. Let's talk about another medium problem on Leetcode today. Maximum number of integers to choose from a range 1, Leetcode 2554. In this problem, we are given an integer array band and two integers n and maximum sum. Then we have to choose some number of integers following the below rules. The chosen integers have to be in the range 1, n. Each integer can be chosen at most once. The chosen integer should not be present in the band array. And finally, the sum of those chosen integers should not exceed maximum sum. And in the end, we return the maximum number of integers we can choose following the mentioned rules. Then in example 1, for the given band array n equal to 5 and maximum sum equal to 6, we can take two integers 2 and 4 that don't appear in the band array and belong to the range 1, 5 because n is equal to 5, and the sum of these numbers is 6, which does not exceed maximum sum, and therefore we will return output as 2 because we have to return the count of the numbers. Similarly, in example 2, for the given band array n equal to 8 and maximum sum equal to 1, we can't find any number which is not in the band set because maximum sum is 1. And now when we try to pick up the numbers between the range 1, 8, only number which does not exceed maximum sum is 1, and that is already present in the band array. So we couldn't find any number and hence we will return 0 as our answer. And finally, in example 3, for the given band array n equal to 7 and maximum sum equal to 50, our output will be 7 because we will be including all the numbers starting from 1 to 7, as none of them is present in the band array because band array only has element 11 and their sum is equal to 28, which does not exceed the maximum sum of 50. So our output will be 7. Now in terms of solution, first thing we can do is convert the band array to a set. This is because we have to search items in the band array, which results in a time complexity of O of n. But using a set reduces this lookup time from O of n to O of 1. And then our goal is to find maximum number of integers in the range 1, n, which are not present in this band set, in such a way that the sum of these numbers is always less than or equal to maximum sum. So to achieve this, we should start by including the smallest number in the range first because it allows us to maximize the count of the numbers. So then our approach will be to convert this band array to a set for O of 1 lookup times. Then we can use a counter to count the numbers from 1 all the way up to n, maintaining their running sum. And for each number, we check two conditions: whether the number exists in the band set. If yes, then we skip it. And if the running sum after including this number exceeds the maximum sum, in this case, we will break out of the loop because now we are done. And if neither of the conditions are met, then we will update the running sum by adding this number to it and increment the counter by 1. Now let's see this in action. Initially, our band array is 1, 6, 5. So we will convert it to band set. And now our band set will have the elements 1, 5, 6. Initially, our counter will be equal to 0 and our running sum will also be equal to 0. Now we will start counting the numbers from 1 all the way up till 5, keeping in mind those two conditions. So first number we see is 1 and we can see that 1 is already present in the band set. So we will skip it. So our running sum and our counter stays 0. Then next number we see is 2. We can see that 2 is not present in the band set and running sum after including this number will be equal to 2, which is less than max sum of 6. So we will increment the counter by 1 and our running sum becomes 2. The next number we see in the list is 3. We can see that 3 is also not present in the band set, and adding this number to the running sum becomes 5, which is still less than max sum. So we will increment our counter to 2 and now our running sum becomes 5. And the next number we see is 4 and we can see that 4 is also not present in the band set. But adding this number to the running sum gives us sum equal to 9, which exceeds the maximum sum. So that means now we are done with all the numbers. So we break out of the loop and the maximum counter we can touch was 2. So that will be our answer. Now let's jump into the code part. First, let's create a hash set to store the band numbers. We can now iterate on this band array to add each number in it to the hash set. Now we can initialize the variable current sum to track the running sum of the numbers. Also, let's initialize our answer, which is the counter, to count all the valid numbers that are chosen. Now we can iterate through all the numbers from 1 up till n. And first thing we check is if the number is in the band set. If yes, then we will skip it. Otherwise, we will check if including this number in the running sum exceeds the maximum sum. If yes, then we break out of the loop because we have found all the numbers with running sum less than maximum sum. If either of the conditions is not matched, then we have found a valid number. So we will update the running sum with the current number and also increment our answer counter by 1. And once we are done with the loop, we can return our answer. Now let's submit this code. Cool. In terms of time complexity, it will be O of n plus m, where n is the given range and m is the size of the band array, because first we convert this band array to a set which takes O of m time, and then we will iterate through the range of n, which again takes O of n time. Hence the overall time complexity is O of n plus m. And in terms of space complexity, it will be O of m for storing all the band elements in a set. So that's all for this video. I hope this video was useful to you. If it was, please give it a thumbs up and share it with others who might benefit from it. If you haven't subscribed the channel yet, make sure to hit the subscribe button and turn on the notification bell so that you never miss an update. Your support helps me create more content like this. If you have any questions or suggestions, feel free to leave them in the comments below. Thanks for watching and see you in the next one.